on the part A, we want to know first off, does the equation explicitly contain a y? Well, this term has a second derivative, y double prime. This term has a first derivative, y prime. There is an x, but there's no y. So there's no explicit y. Therefore, we're going to use the substitution v equals y prime, which means that v prime is y double prime. So, if we make the substitution here, y double prime, which is v prime, 4x times the square root of y prime, which is v, then we have an equation in x and v. Now, we'll notice that since this is dv dx equals 4x times square root of v, that there is a constant solution where the square root of v is equal to 0, which would be v equals 0. So, let's see how we would go about solving this. We can separate this and get the v's on the left, x's on the right. So v prime, which is dv dx, if we divide both sides by the square root of v, that would be a 1 over square root of v times dv, and that would be a 4x times dx, and we can integrate both sides. Well, the 1 over square root of v is v to the negative 1/2, whose integral would be v to the positive 1/2 divided by 1/2. The integral of 4x would be 4x squared over 2, or 2x squared. And then we'll use our constant of integration over here. And we'll solve for the v. So multiplying both sides by 1/2, that'll get rid of the 1/2. And we'll have just v to the 1/2 equals 2 times 1/2 would be 1x squared. Now c1 times 1/2 is going to be some other constant, which we'll just call c2. So then, if we want to recover our v, we need to square both sides to get v equals, and then this is what we'd have, x squared plus some constant squared. Now, once we've gotten the v, we'll do the reverse substitution. So the v was y prime, which we'll say dy dx, equals, and then x squared plus c2 squared. And so we'll integrate. This is directly integrable. We can integrate both sides with respect to x, and we'll come up with our y equals. Now, to integrate this, we'd probably just want to multiply it out. That x squared plus some constant squared, let's see, would come out to be an x to the 4 plus 2 times the constant times x squared plus the constant squared. So the integral of that would be x5 over 5 and 2 constant, and then x3 over 3. And then the c2 squared times x, and then this new constant of integration. We'll call it number 3. Now, since these two things don't exactly match, we can't just replace either one of those with a new constant. So this does actually give us new constants. So here we have to specify x to the 5 over 5. This is going to be a 2/3, and then this constant x cubed, and the same constant squared x, and then our new constant. Now, number 5, let's take a look at these, at least the ones on the left-hand side that are not on your homework, and determine if they are autonomous. So notice on this first one, we have an x, so this is not autonomous. The second one, we have y prime, we have y double prime, we've got a 1. This one is autonomous. And on the E choice, notice we have, so this is not autonomous. And on the G choice, we've got our y double prime, we got a y prime, we got a constant. This is autonomous. And on the I choice, notice here we have x's, which makes it not autonomous. So, if it is autonomous, meaning C and G, we should be able to solve it with our substitution. So for G, we're going to use our substitution, V equals y prime, which means y double prime would be dv dx. And so our differential equation then becomes dv dx equals 2v minus 6. Now, 2v minus 6 is the same as 2 times v minus 3, so we see v equals 3 is a constant solution. This also makes it separable. We'll divide both sides by v minus 3. Multiply both sides by dx, and do the integral of both sides. So on the left we get the ln of v minus 3, and on the right we get 2x plus some constant. We can do the natural exponential of both sides and get v minus 3 equals, now this is going to be e to the 2x times e to the c1. We will replace e to the c1 with a c2. So we add 3 to both sides and we can recover v, which would be a c2 e to the 2x plus 3. We reverse our substitution, which would give us dy dx and And that is directly integrable, so we will integrate both sides with respect to x, and we'll get our y. The integral of e to the 2x would be e to the 2x divided by 2. So this would come out to be c2 e to the 2x over 2. And this one would be 3x, and then our second constant of integration, which we will refer to as C3. It's going to be a different constant than the C2 that we had earlier. Now, there is only one instance of this constant C2, and it's being divided by 2, so we can replace the C2 divided by 2 with a different constant. So, if we use, say, an A to be C2 divided by 2, and maybe a B to be the C3, then here's our solution. Now, in 11.6, you notice that the instructions here are indicating that in many instances you can use the solutions that you already found earlier, and that is indeed the case on most of these, except for like the G choice. So I'm going to go through the solution on G. So we're going to use the substitution v equals y prime, and y double prime would be v prime or dv dx. So that would come out to be an x times a dv dx plus a 2 y prime, which is v, equals 6. So if we rearrange things, move the 2v over to the right side, notice we can factor the right-hand side into a 2 times 3 minus v, and it becomes separable. We also have v equals 3 as a constant solution. So if we divide both sides by 3 minus v, we'd have 1 over 3 minus v dv. Divide both sides by x, we get 2 over x dx. And if we integrate that on the left-hand side, because of the minus here, we get a negative ln 3 minus v. On the right-hand side, we get 2 ln of x, and then some constant of integration. Now, we'll move this negative up here to the exponent. That would be the ln of 3 minus v to the negative 1. And we'll move the 2 up here in the exponent, which would be an ln of x squared. We'll do the natural exponential of both sides, and this will come out to be 3 minus v to the negative 1. Now this is an e to the ln of x squared times an e to the c naught. E to the ln of x squared would simply be an x squared, and e to the c naught is going to be some constant which we will now rename as c1. Now, this is the same as 1 over 3 minus v. if we flip both sides, we get 3 minus v here, and 1 over cx squared. And so we can solve for v by moving the v over to the right side, moving this stuff over to the left side, and we'll have v equals 3 minus 1 over c1x squared. Now we will undo our substitution, and we'll have dy dx 3 minus, now the 1 over c1 we'll call c2, and then x to the negative 2 for the 1 over x squared. And so we want to substitute our initial conditions here. Dy dx is 5, and x is 1. So that comes out to be 3 minus c2 equals 5. So if we add c2 to the left, subtract 5 from the right, we get c2 equals negative 2. So we know that dy dx is 3 minus negative 2, x to the negative 2. That is directly integrable, so we will integrate both sides with respect to x, and we'll get y equals, that would be a 3x, that would be 2x to the negative 1 divided by negative 1, which would make it a negative 2x to the negative 1, and then here's a constant of integration for that integral. We will use our initial condition y1 equals 4 to find this constant. So this is a 3 minus 2, which is a 1 plus c equals 4, or c equals 3. So our final equation then would look like y equals 3x minus 2x to the negative 1 plus 3.